start the question. Anybody can they can raise their hands. Dr. Iqbal Mahmood Iqbal, please go ahead. Dr. Mahmood Iqbal, you want to ask some question? Dr. Achal.
Yes, ma'am, I wanted to ask basically when we are measuring right atrium volume, area or left atrial area, the best time to measure as per the cycle period would be, is it like mid diastole, because in the pictures I felt like the mitral valve is closed, but most of the times we do it when it is like maximum open.
No.
Just,
you are supposed to do it in the frame just before the mitral valve opens.
Just before it opens. Okay.
Yes, that means fully distended.
It's the end of systole of LV.
Yeah, fully distended.
Okay, thank you, ma'am.
Dr. Saurabh. Question by you, Dr. Saurabh.
Hello. Yes, sir. I have a question.
Yeah, go ahead, Saurabh.
Ma'am, can you please illustrate briefly the territorial distribution in the personal short axis at the basal and the mid level?
Okay. One second. You're talking about this model, right?
Yes, ma'am.
Now, what do we have here? Let's see. We have the interventricular septum, correct?
Yes.
Now, this at the anterior part, what is the supply normally? What is closest to it? It will be the septal branches from LAD.
LAD, yes.
And inferior, that will be from posterior.
Right.
Whatever is coming close to it. The best way to remember.
Okay.
So then this is the anterior wall. The anterior wall mostly is supplied by LAD only.
Okay.
Isn't it? When we go to the lateral wall, it could be LAD, it could be circumflex.
Okay.
Correct?
Yes, ma'am.
Done?
Excuse me, madam.
Yeah.
I want you to elaborate again the stroke volume at the LVOT.
Okay, just let's finish with this and then we will go there. Okay.
Dr. Subhash, wait for some time. We'll come back to you. Just give them a time to ask complete questions.
Okay.
So when you come here, you could either be looking at the right coronary artery or you could be looking at the circumflex. Okay.
I think Nandita, the best answer is go to 4-chamber, 3-chamber, and 2-chamber. Let's go back to 4-chamber. Go back to previous image. If you look at this 4-chamber, 2-chamber, and 3-chamber is these parts, just keep on marking it. They are divided into basal, mid, and apical septums. No, not the upper image.
This is base, mid, and upper one.
Upper image. Just look at the upper image of the base, 4-chamber.
Base.
This blue, yeah, this is lateral wall. She's pointing it out as apical lateral. Go to apical lateral.
Yeah.
Then mid lateral. And finally the basal lateral. And now corresponding these vessels, look at the cut sections on apex, apical lateral in apex, mid lateral in apex, and the basal lateral in apex, correct? And
Okay.
all these three vessels, apart from apical lateral, mid and basal lateral are supplied by circumflex, and apical lateral is to a large extent supplied by LAD. We are talking about common consensus. Variations are many. Similarly, you go to septum. Apical septum is supplied by LAD. So where is the apical septum? In this particular image, show the apical septum in apex, cut section of apex. Here is the apical septum, correct?
No, here. Sorry, I was showing anterior wall. Here is the
apical septum. Then mid septum. Show mid septum.
This is the anterior septum and this is the inferior septum.
So mid septum is divided into two parts and then the basal septum. So basal septum is seen in blue in color over here. So that's how we divide these parts. In fact, this image is a little bit haywire. Otherwise, what we have mid and basal septum supplied by RCA, mid and basal inferior wall supplied by RCA, mid and basal posterolateral wall is supplied by circumflex. That's how you should remember all the times. Rest all segment they are supplied by LED.
Okay.
Right?
Yeah, that's right.
Okay. So Dr. Venkatesh Gowda.
Someone was asking what stroke volume, sir.
Yeah, I will come back to that. The line of people are there. Dr. Venkatesh Gowda is there next in the line. Venkatesh, go ahead.
Yes, sir. Madam, this linear edge and trailing edge will be helpful in measuring the septum. Other than that, where it will be going to help?
No, I didn't get your question. What linear?
Linear edge and trailing edge, madam.
Oh,
It will be leading edge and trailing edge. It will be helpful in measuring the septum, or it will be helpful in other things also.
Everything that you measure. See, the concept here is this, that we first told you, that there is a leading edge.
Yes, ma'am.
Go again to that thing. Every echo, okay? Every echo, look at this echo, okay? This has a leading edge.
Yes, ma'am.
And this has a trailing edge.
Correct, correct.
It's a thick echo, so it's well delineated here. Okay. Now, when you measure a 2D, you have to start at the trailing edge.
Okay, ma'am. Okay.
Right? And then end it up at the leading edge.
Leading, correct.
When you are measuring an M mode, you are starting at the leading edge and ending up at the leading edge only.
Okay, ma'am. Okay, ma'am.
M mode, LNL, 2D, TNL.
Yes.
Correct?
Thank you, ma'am. Thank you, ma'am. Yes, ma'am. Thank you.
Yes. Next.
Next is Dr. Sangeeta Chowdhury. Sangeeta, go ahead.
Yes, ma'am, actually wanted to ask, you were talking about fractional area change.
I'm there only. Yeah, tell me.
What you want? Please elaborate on that.
Okay. It's just you have.
You were talking about the fractional area.
Yeah, I'm in that slide only. Just one sec. Let me say. You take the area of the right ventricle. I do not have a slide here. That was amiss of me. Sir will demonstrate. You take the area of the right ventricle in diastole. You take the end diastole. You take the area of the right ventricle in the end systole. 2 frames. Okay. Both in RV focused view. That much clear? That much is clear. Okay. Then the area of the end diastole minus the area of end systole expressed as a function of the end diastolic area will give you the fractional area change. Will give you the EF. And the difference between the 2 areas will give you the fractional area change. Okay. You don't have to कुछ खटना नहीं पड़ेगा इसमें. आप measure कर दो, फिर वो measurement अपना आप वो machine ले लेगा और आपको सारी informations दे देगी. That is the beauty of people who have come to do echo right at this moment. You know, there's so much improvement.
The basic idea is like in RV is a crescent-shaped structure. So we cannot drive volumes in RV in 2-dimensional echo. We need a 3-dimensional echo for RV.
Exactly.
So what we do a fractional area change of RV focused view. So we come to know about how much area has changed with every systolic contractions. And that gives you a rough idea of RV function, how much ejection fraction, or how much area changes happen. Ejection fraction would be area into volume, because we can't take a volume in this because this is just one part of RV. RV has inlet, then RV has outlet, then RV proper, RV OT is also an area.
It's like a hookah.
So that's why we take go back to a previous slide, Dr. Nandita. So if you do this in RV focused view, look at this RV focused view, then you measure trace the inlet during diastole of RV. and then a same inlet or area in systole. Diastolic minus systolic will give you first what is the fractional area change. And if somebody asks you ejection fraction, in that case, we have to go to a 3-dimension set,
Okay, sir.
right? Anything else, Sangeeta?
No, sir. Thank you, sir.
Thank you. Dr. Mohammed Sadab Reja.
Yes, good evening, ma'am. Ma'am, you told and during this left ventricular measurement that in two-chamber views, you sit, you look for the apex. Can you explain again, ma'am?
See, what happens is when you are taking an apical fourth chamber, apical views, no, it is very easy to foreshorten that when you are looking at the apex is not the true apex, but you are looking at a foreshortened view of the apex. That means the ventricular volume is actually less than what the actual volume is. Get it? So what you do, that was a tip actually, that go out in the, when you are taking an apical view, just go distally till you start losing the image. And then come back and make sure that the apex is nice and round. So then you will get the correct volume.
Okay, thank you.
Next is Dr. Pallavi. Pallavi?
Hello, sir. Hello, ma'am. Ma'am, I had doubt regarding MAPSE. Ma'am, if we are measuring LV contractility from EPSS and quantitative by LVEF also by in mid plane of LV in Black's view, ma'am, why do we do MAPSE and what is the normal value of MAPSE, which is more accurate? Is it routinely done?
Question over to sir.
Look, we have a MAPSE came into existence about 40 years down the line.
This. Okay,
And in today's circumstances, we are not talking of ejection fraction, we are talking of 3-dimensional ejection fraction. But where it has been found to be very useful is in intensive care units, where we don't have any good imaging qualities. So if you put a cursor on either medial annulus or lateral annulus, you'll get how much the systolic excursion is happening. Or when she was explaining MAPSE was, the apex is fixed. The base moves towards apex with every systolic contractions. So this is the annulus movement towards apex with every systolic contractions, whether it's medial or lateral. That is in 4-chamber view, 2-chamber view, anterior and inferior, and in 3-chamber view, posterior annulus.
It is not a quantitative measurement. It is just a measurement for LV contraction.
No, it's a quantitative measurements. It gives you a rough idea how much my LV systolic contraction is happening. I have a slide which tells you, like, you can calculate ejection fraction with this MAPSE also. Normal contraction in LV, RV is about 1.7 centimeter. In LV is about 1.5 centimeters.
Like TAPSE, it is MAPSE.
TAPSE is tricuspid valve, MAPSE is mitral annulus.
Yes, sir. RV function. Okay, sir.
And is found to be one of the paper just published in 2022 in JACE. They categorically said it's found to be very useful measurement during COVID times to look for LV function in people who were having a poor LV systolic function and they were on ventilators.
Okay.
Right, Pallavi?
Yes, sir. Thank you.
Anything else you want to ask for?
And I wanted to ask a sequence in which we should do. If you measure LV contractility function, should we always do EPSS and then quantify? Is there a method of
LV systolic function always by ejection fraction in 2022? In this year of 2022 by ejection fraction only. That's to biplane ejection fraction. I'll be showing you in a couple of minutes.
Sequence that we have to do EPSS as a
we don't do EPSS today.
Cavity at Plaxview.
We straightway go to ejection fraction in today's circumstances.
See, the thing is, when you are measuring by modified Simpson's method, what it actually does is cuts the ventricle into about 20 to 22 diskettes. Okay, so each one of these, I just go to that slide. You see, when Sir will explain, you will see this also. That look at this. Can you see these lines over here?
Yes.
So what the machine has done actually is each of these is a small ventricle, small area of the volume of the ventricle. So each of these volumes are taken separately, and then a summation of these volumes are made. So you get a very close to actual volumes by CMR and all the other methods that they have been doing. These volumes are very close to these when you measure by this method. So I didn't go into the other methods like area length or anything like that.
पल्लवी कभी जिंदगी में पिट्ठू खेले हैं?
तो यस सर खेला है.
बस perfect. अगर आपने पिट्ठू खेला है तो LV में these are the 18 pittus which are lying over there. Individual pittus has got individual volumes. The machine adds up these volumes to give you end diastolic, it gives you end systolic volumes. If somebody has not placed pittus, put a 18 carom boards, those carom boards, what do you say, like disc, put one each top of other. Every carom board disc has got one volume. Add those 18 volumes or 20 volumes to give you end diastolic and end systolic volumes.
Sir, ये fellowship pass करने के लिए पिट्ठू खेलना जरूरी है क्या sir?
Yes, pittu is a must, like gilli danda, pittu, these are important things of the life, The amount of pleasure they give you is unimaginable.
Thank you, sir. I got it.
Thank you, sir.
So let's move to Dr. Anuj Kumar. Anuj, you have some question?
Yes, sir.
Go ahead.
In
Anuj.
mode aorta LA view, sir.
Yeah, tell me.
Ma'am, when to take the M mode? During closure of the aortic valve or when the aortic valve is open?
No. Look, what are you seeing here? You have started here, correct? This is one cardiac cycle. This is another cardiac cycle. This is another one. This is another one. This is another one. So what has the M mode really done? It has given you multiple cardiac cycles and the movement of the aortic valve, LA and everything over so many cardiac cycles. So you just drop the cursor and start. And then you scroll back to where you get the best images. It's not one cardiac cycle that you need to have a reference point. है ना? कितने सारे cardiac cycles हैं. अब जो भी चुन लो, जो भी आपका मर्जी है. Whatever you feel is, sorry, whatever you feel is a good delineation of the desired image. Am I clear?
Okay.
Dr. Deepak Kumar. Deepak, go ahead. Deepak, are you there? You're left
Hello, sir.
Yes, sir.
Yeah.
Yes, sir.
Go ahead, Deepak.
Sir, in case of AR, ma'am has said that you have to measure the slope while measuring the pressure half time. But in case of mitral stenosis, madam said that you have to wait till pressure is half. Why it is so?
No. I'm sorry. I think I misled you. Let me just go there. You don't have to wait for anything to happen. This is automatically measured, like in the other one. We were just explaining what is pressure half time. I think, sir, if you can come in here a little bit.
Look at this mitral slope. You look at the point 2. Dr. Nandita, can you show the point 2? Yeah, point 2 to next plus arrow. Show this next point.
Okay, sir.
Correct. You drop a line.
That will give the pressure.
That will give you, this is the peak of a pressure. This is at the rock bottom of the pressure. And then the A wave comes. So the pressure time, how much time the pressure drops to half? How much time it takes to drop to half? So machine will tell you. So this
Sir,
is
why should we measure that? Sir, why should we measure half time?
Wait a minute, Nitin, just hold on for a second. Let me explain. Don't jump in between. Wait for the answers to complete and then come back again.
Okay.
So what we are measuring is, we are measuring pressure half time. With this pressure half time, we get some mitral valve area. Pressure 220 divided by pressure half time will give you mitral valve area, right? On the other hand, this is pressure half time is to drive area in mitral valve region. On the other side, can we go to AR slide, Dr. Nandita?
Yes, sir. Yes, sir.
Here we are measuring the same pressure half time from peak to bottom. What this is telling you, this gives you pressure half time. Here we are not calculating area. the severity or the amount of pressure half time tells you what is the severity of this aortic regurgitation is.
So
Got
can I
it?
just add a line?
Yeah, sure.
Somebody mute. Please mute. Virendra, please mute yourself. Okay. See, the concept here is, if you have a left ventricle which has a very high pressure, then the aortic regurgitation cannot sustain itself. It starts and then it quickly drops. That means what? The left ventricular pressure is very high. And why is it high? Because of chronic aortic regurgitation. Okay, so you will have a pressure half time which is very fast. That means the pressure drops very fast. So the pressure half time will become smaller. Correct. So whereas if you have a left ventricle which is not chronically affected, then the pressure half time will take longer. The drop in pressure will take longer because you have a left ventricle which is compliant, which allows the aortic regurgitation to come in. So that is why we measure this pressure half time. More of this when you go into the specific disease, when you go in aortic regurgitation. To be explained to you in detail and you will understand the concept of this, then you will know why you are measuring pressure half time only in aortic regurgitation and why you are deriving the area in mitral valve. Does it make sense?
Deepak?
Something is happening to his mic. So.
Okay, sir. Okay, ma'am.
Okay. Dr. Nitin, now you have got a chance to ask the same thing again. You were asking something, anything else you want to ask, you can ask now.
Yes, sir. Sir, I would like to just bring to your notice that when I was studying the LV segments, you have given clockwise 1, 2, 3, 4, which is clockwise. But when I went through the net and others, it says it goes anti-clockwise. Here it's 1, 2, 3 goes on the right hand side, sir. Whereas on the net and some of the segments I was studying, it goes on the left side. 1 is in the place of 2 and 2 is in the place of 1, 3 is in the place of 6.
Nandita, go back to previous slide. Look, this is the most confusing thing in short axis. That's why we do not put more emphasis in short axis as on today. We are not going to look at short axis. Why? I'll tell you a reason first. Majority of our fibers are longitudinal fibers which are depicted in 4-chamber, 3-chamber and 2-chamber view. And then we have about 70% of longitudinal fibers. 30% fibers are radial and circumferential fibers, right? So what is said today in 2022 is longitudinal fibers, they get affected first and subsequently this function is being taken over by radial and circumferential fibers. So if you're looking at a 4-chamber view, the longitudinal fiber function will affect, but that will be compensated by short axis view, whether it's base, mid or apex, correct? So at your level, let's not go to the mid segments or basal segment or apical segment. We'll wait for some more time to talk about all those things. You look at a 4-chamber view. 4-chamber view is divided into septum and lateral wall. Septum, mid and basal septum is supplied by RCA. Mid and basal lateral wall is supplied by circumflex, and apical septum is supplied by LAD. Then you go to 2-chamber view. Mid and basal inferior is supplied by RCA. Then rest of the anterior wall is supplied by, go to the previous slide.
Yes, sir.
Rest of the segments, 4 segments are supplied by LAD. Then you go to 3-chamber view. Mid and basal posterior segment are supplied by circumflex. Rest all 2 segments. We do not have apical posterior. We do not have apical anterior septum. We only have mid and basal anterior septum in this long axis view or 3-chamber view. So if you look at the 6 segments of 4-chamber, 6 segments of 2-chamber and a 4 segments of 3-chamber view gives you an idea of coronary artery supply. And for the timing till we come to systolic function, please hold on this slide of basal, mid and apical contraction. And then we'll discuss these points again. At this point, don't get confused yourself. Remember 4-chamber, 2-chamber and 3-chamber views, right?
Yes, sir. Sir, one more last question. Sir, I would like to know to which of the 17 segments are these anterior and these papillary muscles are attached. Some books say some numbers are different. So which according to
don't
you?
look the number. Where the papillary muscle in fourth chamber, we see a papillary muscle where?
Sir, at the cross section of the base here in this picture,
we call them
you
as
have
mid segment, mid lateral wall.
Mid lateral wall, sir. To especially to which segments? Is it
mid lateral wall? This is lateral wall.
Sorry, sir.
This is
Yes,
lateral
sir.
wall.
Okay.
Apical half, apical 1/3 is apical segment, basal 1/3 is basal segment, and the segment which is the mid part which has got a papillary muscle is known as mid papillary or mid lateral wall.
Mid lateral wall, sir. How about the other side? That is anterior attached to which one? Posterior is attached to which one?
No, and then anterior does not have any wall motion. Anterior doesn't have papillary muscle. The next papillary muscle is attached to inferior wall. She's showing inferior wall papillary muscle in two chamber view.
So which are the two walls that are free, sir, in LV without the papillary muscles?
Lateral is attached, inferior is attached. So anterior is free, septal is free, posterior is free, anterior septum is free.
Sir, could you repeat, please? Anterior is free, septal is free.
I think you remembered the reverse way. Sir, I'm just interrupting.
Go ahead.
Remember that the lateral wall has a papillary muscle, the inferior wall has a papillary muscle. Okay, any other wall is free. If you take these two walls out, any other wall is free.
I got it, madam.
Got it? Okay. So similarly, I'm just saying that because we also went through these heartbreaks that you are going now, seeing different things in different books and different things, just stick to the AAC guidelines of the coronary artery supply, because you have to stabilize and standardize yourself at some point of time. You know? So here,
another problem with AAC guidelines is they're not recommending the 16 segment model anymore. They are recommending 17 segment model. Unfortunately,
but that's only the apical cap, sir, and that
and then they're changing the nomenclature of these segments. And if you go to the machine still have 16 segment model.
Okay.
That is the worst problem right now. Either the machine should convert, or AAC should convert, or we should convert.
It's easiest to convert ourselves, sir.
Correct. So
remember both.
So let's remember the segment which are there with. Let's remember the segment which are there in the machine so that everybody looks at the machine and know this is anterior, inferior, posterior, lateral.
Okay, sir. I got it.
When you have taught us, you discouraged those little icons that come in the machines.
Yeah, because that is 19 segment model.
So what would you prefer for the coming generation?
16 segment model.
No, you don't want us to put the icons and
no icons.
Yeah. Because I remember you specifically telling us when you were teaching us. Anyway.
So next is Dr. Rohtas Singh Kalsi.
Good evening, sir. Good evening, ma'am.
Good evening.
Ma'am, in this M mode of LV in the parasternal long axis, can you please explain us the concept of trailing and leading edge way, ma'am, once again, please? Yes.
You want this? Okay,
focus
your eyes. I'll first take this up. Focus your eyes on this line. Can you see this line?
Yes.
Yeah, it's a thick line. Pratibha.
अरे मैडम खाना तो खा लिया सबने, अब पापा ने भी खा लिया, बच्चों ने भी खा लिया, कम से कम माइक तो ऑफ कर दो ना. What do you want us to do?
Sorry, anyway, sorry, sister. No, it's okay. Just switch on. Whoever is not speaking, please switch off your mics because it breaks the concentration actually. So you have this line, correct? And look at this. It's a thick line. Okay. So here it begins here. Does it? Does it not?
Yes.
Are you okay with that?
Yes.
It ends here.
Right.
Are you okay with that?
Yes.
So whichever it begins with is the leading edge because it's leading. Okay, this is your reference point. So the line closest to that is the leading edge. And with the ending line is the trailing edge. Trailing मतलब पीछे पीछे जा रहा है. Leading मतलब आगे आगे भाग रही है. Clear? So when you come down to, wait one second. My mouse is doing funny things today. When you come down to this picture, so you have a similarly, this is a line. So ये आगे भागने वाली हिस्सा ये लीडिंग एज हो गया और ये जो लाइन है ये आगे भागने वाली हिस्सा ये लीडिंग एज हो गया. तो मेम मोड में ये लीडिंग एज टू लीडिंग एज. अभी थोड़ा सा क्लियर हुआ? Wait, sir will demonstrate. He will zoom and make it big and show you, and then I think that's when you will be more clear about. Clarity will come to those who have not yet been clear about this.
Not clear to me also.
In this, when we cut through the LV, ma'am, M mode.
In reference to LV, okay, same thing. This line, it's got a leading edge.
Okay, ma'am.
This line also has a leading edge. So this leading edge to leading edge. Then leading edge of the for the LV and diastolic to the leading edge of the posterior wall. Same concept everywhere. No, nothing different. Just because it's LV or thing, same concept. Why is this thing? Because a 1 millimeter difference comes, and then a lot of in the calculations a lot of difference will come. Okay.
In this septum, where is the leading edge, ma'am? This is the interventricular septum.
No, this is the entire septum. But this line, you know, this line, we are only talking about this line, which is the beginning of the septum. And we are only talking about this line, which is the end of the septum. The septum is a very full thickness. We're not talking about the septum as a whole. We're only talking about the boundaries.
Okay, so we are not, when we talk of leading edge and trailing edge, we are not talking of the entire septum, but the edge.
No, we are not. Because we are talking about a lot of leading edges and a lot of things. Look at here. No, we're not talking about the entire septum. We're only talking about the boundaries. This line, this particular line.
What exactly is this edge, ma'am? How do we define it? Is it the endocardium or something? Like, how do we define edge?
Let us wait. We'll leave it to sir in his practical demonstration. You will be absolutely clear then. When he shows you slowly how he's dropping the cursor and where he's dropping the cursor. Because these are frozen images, they might cause you some confusion.
We'll come back again, Rohtas. Any other question?
So one more, can I ask?
Yeah. Go ahead.
So in this first slide, you had mentioned that in 2D, when we have to see the ventricular systole, we see the downward movement of the interventricular septum, the most downward movement.
Yeah, we do see that also. Yes.
Why not the most upward movement of the posterior wall now? Hello.
Wait, I lost you totally.
Yeah,
it is the most downward systole, this downward this thing, because this is the end systole, the minimum volume.
So can you also see for the most upward movement of the posterior wall also, ma'am? Then like you can see in that way also.
No, we usually, that is a convention that you take the septum. Now we don't change conventions because everybody is working by conventions, right? For example, this convention of leading edge and trailing edge. Everybody, if you don't follow guidelines, if you don't follow conventions, then we will deviate. You will see this will correspond to the ECG of your end of T wave.
Okay.
See? Okay. So that's it. Now, next question.
Can I ask one more, please?
Yeah, sure.
Later on, Dr. Rohtas, that many people are lined up already. Dr. Sanjeev Mathur.
Thank you so much, madam. Nice presentation. I had a question. I had actually two questions. Now, the first question is, you said myocardial performance index. I know sir will tell us more about it, but higher the number, the better is the performance of the heart. Is that what it means?
No.
Worst is the performance.
Okay.
Normally,
It's the other way around.
yeah, other way around. Poor
It's the other way around.
poor LV systolic function. If your number is higher, you have a poor LV systolic function.
Okay, got it. The other question is, these days they have already developed softwares. If you just put up the 4-chamber view, and they will give you the whole calculations. So you really don't have to do calculations. And I know these softwares are commercially available. What is your take on these softwares?
Which company are you thinking of?
So there is one company known as AI, and there is another company known as Ultracon. And I can actually send you the website. So Ultracom has actually come up with, you just put up the 4-chamber view, keep it for like 10 seconds, and it'll give you all the measurements.
Perfect. This is known as artificial intelligence-based ejection fraction.
AI-based softwares, yes.
The only problem with the AI-based ejection fraction is the imaging quality has to be excellent. And if you look at echoes, only 40-45% ejection fraction would be calculated perfectly by AI-based ejection fractions. Whatever you will give,
they claim about 90 to 95% efficacy.
Based on the proper imaging quality. Try this tomorrow, because if you don't give them a good imaging quality, they'll not give you a good ejection fractions. Whatever they claim is based on the demonstration models. Claim is not based on a routine examination models.
See, basically AI is all about matching their own protocol parameters that they have. They have to find matching things, and then the artificial intelligence takes over and does the measurements. So I don't know whether they are validated in India or not.
It is there already. Dr. Nandita is there. GE has come up with this artificial intelligence. We conducted a program for GE where everything is like LA, LV, every measurement is available on these machines. In fact, not GE, I still remember about 5 or 7 years down the line, Siemens was the first one to show all these artificial
Siemens was the first one, yes.
To show artificial intelligence. They showed these artificial intelligence in coaching, in one of the conferences, when they demonstrated the Siemens machines. They are very good. Only thing is you have to have a good quality of images. And as far as I don't know about that system, what we see in our lab, we have see approximately 45 to 50% people having good imaging qualities. Rest of them are really, really horrible.
Right.
Okay. Is that okay, Routes?
Yeah. Thank you.
Right. Let's move on to Dr. Mahesh Padsalke.
Sir, from a lot of people are giving in the report nowadays RVEF. So whether it is needed to be given RVEF, or whether they are making this RVEF reading on mapping like Simpson's method, or they are making it on TAPSE.
RVEF is not there. It cannot be calculated without 3 dimensions echocardiography.
Okay, sir. Okay.
So if they are writing RVEF, either they are doing a 3 dimensions echo, or they are just driving it from some method. I don't know.
Sir, some machines give that, but that is derived from the fractional area change and looking at it at a function of the thing, but it doesn't work for RV.
Because in the common literature, what is said is the ejection fraction of right ventricle is the more cumbersome process for echocardiography, and 3D ejection fraction of RV correlates very well with MRI ejection fraction. So please, for this timing, whatever the people are writing, just ask them in which method they are utilizing. The correct method is 3 dimensions echo.
So they cannot use this with the TAPSE actually.
TAPSE will give you a systolic contraction.
Yes.
Report TAPSE as TAPSE.
Okay. So normal TAPSE is 1.7 centimeter and MAPSE is 1.5 centimeter.
1.5 roughly.
Okay.
So TAPSE is better, or sir, fractional area change is better?
To honestly tell you, if you put them all these things together, TAPSE has been found to be the much better parameter for looking at RV systolic function in 2 dimensions. And if we go for 3 dimensions echo, ejection fraction has found to be a better ejection fraction in 3 dimensions echo, better than TAPSE and MAPSE.
Okay.
Thank you, sir.
Okay. Dr. Subhash Chandra, you disappeared and I could see your name right now over here. Dr. Subhash, are you there? Dr. Subhash is tired, I believe. We will come back to Dr. Harsh, you want to ask some question?
Sir, yes, sir.
Go ahead.
Ma'am, can you please show the how to obtain the coronary artery view? 1 second, please. Yes,
Harsh, have you gone to picture anytime when the picture movies were sold in a black? Doka 4, Doka 4, Doka 6, Doka 8, Doka 10. Have you seen
yes,
that
sir.
time?
Yes, sir.
So 2 of your friends should sit together. One should say 4-chamber view, 4-chamber view, 4-chamber view. Others should set mid and basal septum, mid and basal septum, mid and basal septum, and third voice should come RCA, 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 RCA. That's how 3 of you can really remember all these segments very easily.
Sir, not this. Obtaining the coronary artery view. The last image.
Coronary artery view. Wait for some time. Wait for about 10 years. At least 10 years.
That was just, teasing you, because I don't know. With every echo, you will learn something new. That is my take on this.
Japanese people, they sit down, hold it together to look for only one coronary artery, either left or right. For 8 hours, they'll keep on looking at these coronary arteries. And if they get one coronary artery in a day, they feel their day has been utilized.
Sometimes, sir, we do get these things. So we actually see plaques also in the left main or in
Hananita is not at their purview to level at this to talk about coronary arteries, because tomorrow they'll go and say, look, we can see a coronary artery is an echocardiography, and then they say, who taught you this?
Okay.
So at the present moment, coronary arteries are seeing only proximal few millimeter of coronary arteries are seen in routine 2 dimensions.
Okay. Again, this is not something routine, and this is something you will develop on your own later.
Harsh, anything else you want to understand?
No, sir. Thank you, sir. Thank you so much.
Okay, Dr. Shashank.
Hello, sir.
Ahead,
I want to ask about the myocardial performance index. The importance of myocardial performance index is what? As we are already taking LVEF.
Is virtually something like looking at systolic functions. This is one where we do not look at a systolic function by measuring ejection fraction. This is one of the surrogate parameter for looking at systolic function. What she has said is look at the mitral valve closing and opening time and divide this time by ejection time to drive a Doppler-based myocardial performance index. It gives you a rough idea how much my LV function is there or not there. Again, the value comes in places where we could not find a good ejection fraction by good imaging qualities. Okay. Right? So those cases actually of use.
So, sir, how the sample volume should be kept in this view?
Sample volume is very simple. One sample volume at mitral valve level. The first one actually is shown over here. So mitral valve closing and opening time, that is A parameter. The second sample volume is at aortic valve level in 3-chamber or 5-chamber view. And you look at a opening and closing time. That is B parameter. A minus B divided by B will give you myocardial performance index.
Sir, what is the normal range for this?
0.46. We have already written over there.
Sir, sorry to interrupt. Just wanted to ask why it is written tissue Doppler, because that was mitral inflow and this was LVOT outflow.
There are two images are there. This image is on a tissue Doppler based. This is Doppler based. Next image, show the next image, Dr. Ranita. Yes. The first image on left hand side is shows on a Doppler base. The second image is shown on a tissue Doppler base. So forget about it. We can do in both of them. In fact, if you ask me at this period of my life, how do I do it? A myocardial performance index, I have to do it. I do it in tissue Doppler base because I'm getting everything in one
Both
frame.
in one image. Okay, sir. Thank you. Thank you.
So tissue Doppler sample, how should be kept it in tissue?
We'll come to tissue Doppler. Wait for some time. Let's start our journey from Delhi to Delhi to Kerala. We have hardly reached to Faridabad at the time being.
Sorry to interrupt, sir. Which one is preferred, the tissue Doppler one or the
Both of them are preferred, Pratibha. Both of them are preferred.
Thank you, sir.
Okay, all right. Dr. Shashank, you are over. And now, Dr. Subhash, I could see you, Dr. Subhash, you were asking some question and you are not seen any more over here. Dr. Subhash is like waxing veiny phenomena, you know. Dr. Subhash Chandra from Agra. Dr. Subhash, are you there?
I think he may have muted his mic and he probably is having trouble with it. Or
Yes, I'm here.
Thank you, Dr. Subhash. We can't see your face. Please show your face, like how a young, energetic, dynamic person is attending these workshops. Go ahead and ask your questions, Dr. Subhash.
Yeah, I was just, can you elaborate a bit about stroke volume?
just 1 minute. Yeah, here is the slide. Now, this is the easiest measurement of stroke volume and also probably the most reproducible, the way I have shown it here. What do we need for it? What we need to know is the amount of blood passing in one cardiac cycle through a particular point of the heart. And for that, what we have chosen is we've chosen LV outflow tract. So measuring, how we measure LV outflow tract, like I told you, we measure it from the leading edge, sorry, trailing edge to the leading edge. And this is the, suppose this is the diameter that we get, say 2.4 centimeters. Next, the parameter we need is the velocity time interval of the blood flowing through the LV outflow tract. So we choose the apical 5 chamber, open out the LV outflow tract at its widest, place our pulse wave Doppler, the gate of the pulse wave at that point, and then record the Doppler tracing. So far, so good?
Yes.
Okay.
Yes.
Now, the second measurement, the first measurement we've got, the second measurement that we are supposed to get is we are supposed to trace this particular envelope and get the LVOT, velocity time interval, or the LVOT VTI. Done?
Yes.
So we've got the LVOT diameter and we've got LVOT VTI. The machine automatically, through this formula, gives you the stroke volume.
Okay.
Okay.
Thank you. Thank you, ma'am.
Okay. Great.
Dr. Subhash, where do you want to utilize this LVOT stroke volume?
I want to use it in fluid therapy, whether I'm improving the stroke volume of the patient by giving fluid or I'm pushing the patient in left ventricular failure. And so far, my stroke volume is improving. I will keep on giving the fluid. Fluid therapy in sepsis shock. Fluid therapy in any shock patient where I want to give fluid.
Okay.
If my fluid therapy is working, then stroke volume will keep on improving. Once it becomes stationary, I should stop giving the fluid. Otherwise, patient will go and left ventricular failure.
Okay. Okay. Good. Good.
Any other question?
Dr. Prasenjit, go ahead, Prasenjit.
Sorry, this is regarding the collapsibility index of IVC. I don't, I just didn't get it. If you can just help me with
that. Just one. You have measured the IVC in 2D. Now drop your cursor through that point and take an M-mode tracing.
Achha.
Okay. Now, whenever you've taken an M-mode tracing, one second, you will get a largest diameter.
Okay, same with like the left ventricle thing.
Yeah, feed in the largest diameter.
Yeah.
And feed in the smallest diameter.
Correct.
Now, the difference between these two, the largest and the smallest, is the amount this IVC has collapsed.
Correct, ma'am.
When expressed as a function of the largest diameter, this becomes the collapsibility index.
Thank you. Thank you.
Dr. Pranjal, you want to ask something?
No, sir.
Okay. Anybody would like to ask some questions before we switch on to a live demonstration by Echo?
Yes, sir. I am Dr. Prakhar Gupta, sir.
Prakhar, go ahead.
I want to show that what is the exact position or what is the exact place at which IVC dimensions should be measured.
Go back, Dr. Nandita, show just distal to the hepatic vein. I'll be showing the dimensions live, just distal to hepatic veins.
If you cannot see the hepatic vein, you can take a 3 to 5 centimeters.
No, the new guidelines classically says 3 to 4. You can use 3 to 5. Here is a hepatic vein. Can you show a dilated hepatic vein? Yeah, it's here. And distal to hepatic vein that's a point where you should measure the IVC.
That one means the proximal most hepatic vein, because
distal to hepatic vein. Proximal would be closer to RA.
No. He means to say, sir, the proximal most hepatic vein.
Correct. Only hepatic vein.
Because the hepatic veins drain at different levels in the IVC.
True. The first one.
Yes. Thank you.
Anybody else?
Yes, sir.
Are these values of TAPSE, MAPSE, and sir myocardial performance index, they are same for adult and pediatric age group, or are there any difference?
They are same. They have not been a significant variation in these values.
Okay,
sir.
Go ahead, Shashank.
Sir, can you tell me the importance of fractional shortening?
Fractional shortening of what? LV or RV?
LV, sir.
LV. Nandita, can you go back to the first image? Next one, yeah. Fractional shortening, if you look at it, is 40.4% in this. Normally, our LV contracts to 1/3 of normal contraction. Like LV, if it's 40, it reduces by at least 12 to make it 28. So 33% approximate shortening is there in our LV in majority of cases. So this parameter can sometimes be used in poor LV systolic function. When we see the fractional shortening is less, then we think possibly our LV function is LV is poorly contracted. Otherwise, nothing more than that. We are not utilizing any one of these parameters in day-to-day practice. Whether this is end-diastolic volume, whether it's fraction shortening, end-systolic volume, ejection fraction, IVS ratios, we are not utilizing all those 5 parameters which are below the line of this particular image.
Okay, sir. Thank you.
Anybody else? Some questions before we go for live? Mohammed.
Sir, to determine the hypertrophy, we need to know the LV mass, right? So how to get this LV mass? Is it by Simpson method or something?
No. We had actually included this. All you need from your end, all you need to do is measure this.
Okay.
So you have measured this IVS and LV. So the machine does the rest. It will calculate the it will calculate the LV mass and give it to you on a platter. So you just report it.
And this is preferably done in short axis view, not in long axis view, preferably done in short axis view at papillary muscle level.
Just index it. Feed in the body surface area and index it. That's it. That's all you need to put in your report.
Sir, I am Dr. Prakhar. Hello.
Go ahead, Prakhar.
Sir, I just want to know that when we measure the septal length or septal width, you can say by M mode or by direct looking and calculating the this septal thickness, sir. Then it comes different at different stages of M mode. So should we rely on direct measurement or should we rely on M mode?
No, look, At your level, again, we are measuring the septal thickness during diastole at the basal septal level, basal anterior septal level. Dr. Nitya, can you show that cursor where we measure this anterior septum? Here is anterior septum which you are measuring. So this anterior septum we are measuring in basal anterior septum in our normal imaging qualities. Okay. This is normally up to 15 millimeters is considered as normal. If we go to left ventricular hypertrophy like hypertrophic cardiomyopathies, we call them as 15 millimeter or more, or 13 millimeter or more in siblings of hypertrophic cardiomyopathies.
Okay.
Right. But there are several phenotypes of hypertrophic cardiomyopathy. What do you mean by phenotypes? Means the varieties of hypertrophic cardiomyopathies. Now, when we talk of this, we talk of a generalized involvement of septum and posterior wall and other segment. Can we show the next slide, Dr. Nandita? Next one.
Which one? The concentric.
Yeah, look at this. This is what the second tops, right hand side. This is concentric, not this one.
Remodeling.
No, this is not remodeling. I'm saying concentric hypertrophy.
Yeah,
concentric hypertrophy is with all around all segments that are thickened, and they are thickened more than 15 millimeter in thickness. This is itself is a topic when we talk of LVH. So there are many variety of LVH and there are many phenotypes of hypertrophic cardiomyopathies. It could be apical, it could be just basal anterior septum thickness, which we call as sigmoid septum, or mid septum thicknesses. Multiple varieties are present of left ventricle. At your level, you should talk of 15 millimeters or more in a basal anterior septum.
Sir, I just want to know in respect to the hypertensive hypertrophy.
Look at the basal anterior septum and basal posterior wall. If both of them are more than 15 millimeter, you think of a hypertensive heart disease.
Some of your lectures in YouTube, you have written 12 mm.
I do write 12 mm or more, but what I'm talking of hypertrophy at this present moment is when we really consider them hypertrophic. Anything more than 12 is considered as hypertrophic to be true. But issues are there, many variabilities are there. If you look at American Society of Echo, they say 10 millimeter or more is considered as hypertrophic.
Yes.
So we said in our lectures 12 millimeter. When we talk of hypertrophic cardiomyopathy, we say 15 millimeter.
Okay, sir.
Similarly, I said if I'm looking at the sibling of hypertrophic cardiomyopathy, I'm talking of 13 millimeter.
Sir, we as a beginner do some mistake in measurement.
12 millimeter or more in hypertensive heart diseases.
The best thing perhaps would be, sir, if I can just pitch in a
Sure,
little.
go ahead.
Get the LV mass.
Yes.
Get the LV mass, and if your indexed LV mass is going somewhere beyond this, get the RWT and try and give it a name.
115 in male.
I think here the confusion is, should I label this as an LVH or should I not?
Nandita, at their level, we should talk of more than 12 millimeter if they're talking of hypertensive heart disease for septum and posterior wall, because otherwise it will become really confusing.
Sir, I think the confusion is, if I give a report, do I say this is LVH, or if I get a report, can I say this is LVH?
That's what I'm trying to say is like, if I'm really looking at LVH, forget about a criteria more than 12. If we look at about 12 to 15 millimeters, a better cutoff, then we possibly say that definite hypertrophy is present. And the word which people often write is like, they write the word as mild concentric LVH. This word mild should never be there. You should measure your septum and posterior wall. They should be at least more than 12 millimeter. And if they're 15, they'll be really good enough to talk about hypertrophy.
Sir, we as a beginner do mistakes. Our dimensions at 2D level and with M mode usually differ. We M mode and direct dimensions measurement usually differ. Then
in 2022, we should talk of a direct measurements. We are not talking of M mode measurements anymore.
Sir, what is the main importance of M mode in the modern echocardiography?
M mode is in modern echocardiography is many things are useful in modern echocardiography. To name a few, in ICU setups where we're looking for a MAPSE, LV systolic contraction.
Okay.
Please silent your mic, people who are not using their mics. And like TAPSE is one place we are using it to a large extent.
Okay.
Then these measurements are used, M mode measurements are used, like flow propagation velocity, M mode measurements are used. So many M mode utilization are still positive. Then second important thing is, like, as you will progress in your course over a period of time, you will start realizing the frame rate of M mode is much better than the frame rate of two-dimensional echo. The frame rate of M mode is 1000 to 1500 frames per second.
Okay.
So imaging quality, look at this image which Dr. Nandita is showing right now. If you look at this image, if you have to measure your two dimensions septal thickness versus two-dimensional septal thickness in mitral valve of M mode versus two dimension, it's better to measure in M mode rather than to measure in two dimensions.
Yes, 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 yes.
So
but
that is,
sir, the but problem comes at what exact point we place the cursor.
I'll try to show you all those things. Give me a second time, because give me some time. I'll show you all those measurements in a.
That is also the guideline, you know, where you have to put your cursor.
Just distal to the tip of the mitral valve leaflets.
Yes. Sometimes it becomes very difficult to do a regular alignment there.
Impossible. Then we use anatomical M mode sometimes.
Okay, okay, sir. Okay, sir.
You will have difficulty. 50, as sir has already said, no, 45% of patients give you a good window. The rest 55 do not give you a good window. So go into the field thinking that you are not going to get a good window, and you have to improvise.
Yes,
so
yes.
You have to go to other windows. Some people like to COPD and all, you will never get a Plex window.
Yes, yes,
You're always working with apical and subcostal windows. So you have to improvise and you have to think, but mention in your report from which window what was done, if it's not a conventional.
Yes, sir. In COD, it comes at epigastrium.
Yeah, of course.
Definite, man.
Dr. Mathur was saying these artificial intelligence method give you 95% sensitivity of calculations. You know, like
no, sir, no.
So it's not possible, because 95% would be ultimate. You know, like
95% of the 45%, sir.
So this is not easy. You know, like it's very difficult to get good images. It's like, believe my words, even doing an echocardiography for more than almost 40 years, 36 years, 1986 and 2022. We
Sir,
still,
artificial intelligence can never be reliable.
It will be reliable. It is. I'll show you our video recording. If you have some, we'll have some time. I'll show you a video recording of those cases which I did with artificial intelligence machine. But those were the cases which had excellent imaging quality for demonstrations.
Yes.
And so I have to choose out of 10 patients. I could choose only one.
And it is an art. It is an art which comes by very much experience.
It's a learning process. You know?
Yes.
It takes time to learn.
Yes.
Bottom line is a good image.
Sanjeev, whatever you say, Sanjeev is always fond of thumbing up and will eventually be established. Sanjeev, whenever you go for a marriage, every girl is shown as beautiful as possible, you know. That is what artificial intelligence is. And when they take off all those masks and everything, makeup and everything, then the real true picture comes. So that is what how I put artificial intelligence is. You cannot. Who created artificial intelligence? Man.
Man. Definitely.
Can you rule man minds by artificial intelligence? Never.
No. Artificial intelligence is made by us. It can't overcome.
It is like something where we are trying to substitute manpower with artificial intelligence.
Yes.
But
it can't like confirmatory, sir.
It cannot be 100%. You know, like ultimately, it will be taken over by my mind. Our mind would be taken over by artificial intelligence. Anyway, let's forget about the topic. Anyway, go ahead with the good questions.
Thank you, sir. Thank you, sir.
So we'll stop over here, and then let me show a quick measurements of today's. Give me some time, and I'll stop recording over here, and then
stop sharing, sir.
Yeah, stop